This video is on relations versus functions. We know how to tell if a relation is a function in words and on a graph. So we're going to look at some examples of non-functions. Previous video showed examples of functions. So let's look at some examples of non-functions. So one type of example we can have is a set of coordinates. So I'm going to have a set, and I'm going to write in some coordinates. So 2, 4 is a coordinate. 1, 4 is a coordinate. 2, 6 is a coordinate, and that's going to be the end of my set. Now, this is a non-function because if we look at the x values, we do not have them all different. The x value of 2 happens twice, but that does not automatically mean it's not a function. What we have to do is we cannot have repeating x's unless their y's also repeat. So we want to know why is this not a function. So if we look at these, specifically these two x values, we also have to look at those specific y values. So my first y value is a 4, and then on the other one, my y value is a 6. These y values do not repeat along with the x's, so that means that this is why it is not a function. So the x value of 2 repeats without y values repeating. This is why it is not a function, because those y values on those two coordinates did not repeat. If they had repeated, if this was 2, 4 and 2, 4, that would have been a function. Another way of looking at this could be a table of values. So I could say my x, y in a table. So I could have a coordinate of 1, 4. I could have a coordinate of 2, 4. I could have a coordinate of 3, 1. And I can have a coordinate of 2, 6. So again, we have a table of coordinates. I need to look at my x value. So again, this is an example of a non-function, because if I look at my x values, I have two x's that are the same. But again, we have to remember that this does not automatically mean it's not a function. We have to then look at those y values. This is the only time we look at the y's. So if we look at this y value, it's a 4, and this y value is a 6. These also do not repeat, so that means it's not a function. The x value of 2 repeats without the y values repeating. So the same reason for the first example we did, because the x value repeats, but the y values do not repeat with them. Another way we can look at relations is in a mapping diagram. I'll have my mapping diagram where I have my two ovals and I have my input of x's and my output of y's. I'll just put some numbers in here. So I'll have 1, 2, 3, 4, 5, 6. But then what we look at is the arrows. So I'm just going to draw some arrows here. Just going to look to see what happens with them. I'm going to draw a couple of arrows. Okay. So I made this a non-function because if we're looking at our x's, at the 1, I have 2 arrows coming from it. Now, this first arrow goes to a 4, and the second arrow goes down to the 6. The 2 has only 1 arrow, and the 3 only has 1 arrow. But because the 1 has 2 arrows coming from it, this is not a function. There are 2 arrows coming from x of 1. So the x value of 1 has 2 arrows, which means a mapping diagram is another way of writing coordinates. This would be 1, 4 and 1, 6, 2, 5, 3, 4. So the 1, 4 and the 1, 6, the x value repeats, but the y value does not. This is why this is not a function. And another representation of a relation is in a graph. So I will have my x and y axis graphed first. So this is my x, this is my y. And now my graph itself is what I'm going to focus on. So here's my graph itself. Now I want to draw a vertical line. So if I drew a vertical line over here, it wouldn't even cross the graph, and that's perfectly fine. But I need to draw a vertical line that crosses the graph to see what happens. Now, if any vertical line crosses the graph twice, it's not a function. So if I drew a vertical line here, it would touch that graph only once. But if I drew a vertical line here, it is actually crossing my graph at 2 locations. Here and here. It's crossing it at 2 different locations. That means that this x value has 2 completely different y values. This is not a function because a vertical line crosses the graph, again, not the axes, the graph more than once. So another way of putting this is that this fails the VLT, that vertical line test. In order for it to be a function, it has to pass the vertical line test, like this one. This one passes the vertical line test because every vertical line crosses only once. This one fails the vertical line test because any vertical line that I drew in here could cross it twice. So just this one vertical line that I drew automatically proves it fails. So then it has to fail. This is no longer a function.